So this topic is about inverse functions. So number 16 is basically this. F of x is 8 plus, or x plus 8. So that's a function. We want to find the inverse of it. To understand the inverse, let's first evaluate a few values of f. Let's say, so if we have x, we have y. Let's plug in a few values here, maybe 0, maybe 1, and -2. So these are from the domain. This is a range of the function. We're going to plug these values into that function, evaluate them, and see what we get, see what's the y. Okay, so what is f of 0? If you plug 0 into the x, what do you get? F of x will be 8.
8.
That's right. What is f of 1? If you put 1 here, it will be
9.
That's right. F of 1, basically we substitute x with the values from here, and then we evaluate this to get the y, because f of x equals x plus 8, which we also call y. So f of x equals y. So this is 9. What is f of -2? If you put -2 here, -2 plus 8 will be?
-1.
Not -1. If you put -2 here, plus 8 would be 6.
Oh, yeah.
Okay, so basically we use the function f to go from the domain to the range. But sometimes we need to go back from the range back to the domain. So if we use f here, that's f. What do you think, what's the function we use to go back from the range to the domain? That function is what we call the inverse function, and its symbol is something like this. So the name of the function and the little -1 here, it's not a power, it just means the opposite or the inverse function of the function f. So this is what we call f inverse. The inverse of f is this, that's the symbol for it. Okay, just like going from A to B, let's say you want to go from point A to point B. So let's say you take this path to go from A to B, okay, path 1, and the opposite path is the one you take to go back from B to A. So in our example, we use the function f to go from A to B, but to go back, let's say you take another route or another way to go back to B, another formula or function. So f minus 1 is basically the inverse function. Okay, now that we know what the inverse function is, let's say let's try to find the inverse function of f. So basically to go from here to here, you plug 0 into this, you get 8, but we need another function f -1 that if you plug 8 on it or in it, if you plug 8 into f of 1, what should you get? If we find this function, right, and we plug 8 into it, what should we get back? If you look at this table, so
0.
we get 0, exactly. So if we go from here to here, we plug 0 or x into the function, the actual function. But to go back, we need some formula or, that we call the inverse function. So if you plug 8, we get 0. If we plug 9, we should get
1.
1, and so on. Okay, let's find it first and then test it, see if it works. So find f There's a couple steps we need to follow to find the inverse function. So first, as we said earlier, f of x is the same as y, because every time you plug x here, you get y back. You get this y here, here, and here. So if you have a function like this, first you want to substitute f of x with y. So in this example, we're just going to write, instead of f of x, I'm going to write y, so it will be y equals this, x plus 8. Then you want to swap x and y. You want to swap them means one. Just switch their places. So the x goes over here. So this turns into x equals, and the y goes to this side, plus 8. Okay, so you swap. And then we're going to solve this for y. We're going to get the y by itself. Well, for y. What do you do to solve this equation for y, or to get the y by itself in one step? Look at this equation. We want to solve it for y. What do you do to get the y by itself? Everybody? What do you do?
You move the
You would
you subtract.
That's right. We just need to move the 8 to the other side. So this turns into what? X.
Minus 8.
That's right. Minus 8 equals y. So once you get the y by itself, that's the inverse function. That's f of -1 of x. F inverse function is basically this. So two steps, two simple steps. Just swap the x and y, and then solve that equation for y. We want to find y. Once you find the y, the expression that's equal to the y, that's basically the function. Then just name it, give it this label, or you can write it nicer like this. You can start with the inverse function, and that's basically it, x minus 8. Okay, so now let's test it. How do you test this again? See if this works. So basically, this is the function that takes us from the range back to the domain. So if you plug, as we said earlier, if we plug 0, we should get
8.
8. That's right. Let's try that. Let's do f -1, or the inverse of f of 8. And if it's 0, then we're good. Otherwise, something is wrong. So f of -1 is this. What would f of -1 of 8 be? If we plug 8 here, it will be
0.
It will be 8 minus 8, right? Because the x we want to plug is this, so it will be 8 minus 8. Again, we say, is it equal to 0? Yes, indeed, 0 equals to 0. So that works. It should work for every number from the domain. You should be able to get back to the range. Now let's test the other one. If you look at f of 9, if you put 9 here, right? f -1 of 9, 9 minus 8 will be 1, which is exactly what we have here. Okay, so f inverse of 9 is 9 minus 8, which is 1, which is good. And the last one, does it work for the last one? -1 of 6. If you put 6 here, what do you get?
-2.
-2, right? -2. That means our inverse function works. Okay, so these values here, so this 0, this 1, and -2 are these values here. So we have this value, you have 1 and 2. So that's the concept of an inverse function. You're just basically going backwards. So the function must be 1-to-1. That means for each value of x, there's a unique, or there is exactly one value of y. So this is 1-to-1, 1-to-1, 1-to-1. Each value of x must have only one unique value from the y. So the function must be 1-to-1 in order to find the inverse function. If it's not 1-to-1, if it's something like this, for example, 0 has 2 values from here, this is not a function, this would be just a relation. And a relation would not be would not have an inverse, because an inverse function is consistent. If you plug 8, you have to get exactly one value. In this case, is 0. So you can't get 0 from plugging two values. If you plug 8, you must get 0 every time. So you can't plug different values and get the same value here. Same thing with, let's say, I'll give you an example with a blender or a mixer. If you plug fruits in it, right? If you plug, let's say, oranges, what do you get back? If you plug oranges into a blender or the input,
The orange juice.
that's right.
Juice.
You get some orange juice back. What do we call the orange juice? If this is the input, the orange juice will be
The output.
output. And this is consistent. If you plug this, you get this. I don't know if we can invent a machine that takes us back to this. It will be remarkable, right? Do you think we can find an inverse function to this blender? Probably not, right? I don't think we can put oranges together. And I mean the orange juice, we can go back in an inverse function. But the point here is, I just wanted to make not to say that this is an inverse function, but to say that a function is consistent. If you plug orange juice, oranges, you get orange juice every time. You can't plug orange juice and get this time orange juice, and another time you get, let's say, apple juice. It wouldn't make sense. Okay, that's why the function must be one-to-one in order to have an inverse function. If it's not an inverse function, if it's not one-to-one, then to go back from here to here, we don't know. Do we use 8? Do we use 9? It doesn't make sense. Okay, so it has to be a one-to-one function. That means each value of x has a unique value from y. That way we have consistency. If we're going to go back, just take that route from 8 to 0, 0 to 8. So if a function is not one-to-one, it does not have an inverse function. Okay, so in this case, our relation is a function. Okay, it's a one-to-one, so that's why we easily found the inverse of it. So if you plug 8, we get 0. If you plug 9, you get 1, and so on. So a function is a one-to-one. That's the concept of inverse functions, and the each value of x has exactly one value of y, as I said. But sometimes the function is not one-to-one. So question number 32 is also find inverse of f of x. I believe it said -6 or something like that, -7. So that's a function. First, before you find the inverse, again, you want to know whether it's an inverse function, it's a one-to-one function or not. So if you do a little graph quickly like this, so the graph goes like this and this. So this is a constant function. X is -7, it does not change. So f of x is -7, it does not change. Basically, so f of x equals -7. What's the other name again for f of x? What's the other notation for f of x? The y. That's right. It's the y. So this is basically the y. So for this function, it only has one value. Whatever you plug here, when you do a table of x and y, whatever the x might be, there's only one outcome of the y, and that's just -7. Any value you plug, these are not ones, it's just dots. Okay? Any value you plug here of x, it doesn't matter which value you plug, it will be just, for example, some value here, some value here. It's fixed, it's a constant function. Its value does not change. and f of x equals y. So the y is -7 will be somewhere here. Okay, so that line will be like this. That function will be a straight horizontal line. Okay, so that's the graph of this function. It's a straight horizontal line. So the y does not change, it's fixed. It's -7, but the x can change. The x can change. What does that mean? For example, if you take any values of x, 0, 1, 2, -5, -4, if you plug any of these, what do you get? The same outcome, which is, what is f of 0, f of 1, f of 2, f of -5? That outcome will be the same number, which is?
-7.
That's right, negative.
-7.
And this is definitely not 1-to-1. It's many to 1, or infinitely many to 1. So any number from here basically takes you to -7, and this will be inconsistent with the 1-to-1 function, like we said, like a blender. If you plug orange juice, you get orange juice every time. We may not go back with this specific example here. It's impractical. You may not go back to the exact same input, but again, it's 1-to-1. Whatever you plug here, you get the consistent outcome every time. It cannot be something weird like here. So basically, if this is not 1-to-1, can we find the inverse of it? So this function, we said,
No.
not 1.
No.
So therefore, it doesn't have an inverse, not 1. So no inverse. Okay, I hope that makes a lot of sense. You guys understand what I'm talking about here? Everybody, does that make sense to you?
Yes.
Okay, so that's the concept of inverse functions.
Like, what if it's just find the inverse of a single digit? Like, if it's 2 or 6, I don't know.
The inverse of a single digit, right?
What's the answer?
Okay, let me.
Yeah.
I think I know what you're talking about. Let's say the function, instead of a function, we have values, right? Let's say 3. Just making up some values: -1 and 4, 2 and -7. So this is basically these are pairs from a function. So let's say find f of negative, the inverse f -1 of 4, for example. Find f of 2, and find f of -1 of 3. So one of them, again, one of them takes you from the x to the y. Which one takes you from the x to the y? The f or f inverse? Which function? Let's say f and
The,
f inverse.
the F.
Which one takes you from x to the y? Which one of these takes you from x to the y?
The F.
The f, right? To go back,
F.
The F
the f what?
is the F inverse.
F
To
inverse.
go
F
back,
-1, -1.
That's right. So when I say f -1 of 4,
F -1.
it means something from here to here. So what is f of f -1 of 4? What is f -1 of 4? That means we're going from the y. So start from the y. What's the equivalent x? What is f inverse of 4 from these values?
-1.
Exactly. So since we have a -1, that means we start from here. We're going back, and that's -1. What about this one this time? We need f of 2. It's not an inverse. So we started from the x going to the y. What is f of 2 according to these pairs?
-7.
That's right. So f of 2 is -7. And the last one, it's an inverse because of -1. So what is f inverse of 3?
0.
0.
That's right. It's 0 right here. So f of negative 3. Okay, so that's another type of question you may see about inverse function. Fiona, does that make sense now?
Yes, but my question was different. Like, my question was, if f of x is equal to 2, what's the f inverse?
Okay, so first, is this a one-to-one function?
No.
No.
I don't know.
No.
It's not a one-to-one function. Why? Same reason we said earlier, right?
Yeah.
You have multiple
So
numbers.
what is this number again called? So f of x equals 2 equals
Why?
y. So the y is always 2. So the y is always 2. That means this column will not change regardless of the value of x. Doesn't matter what you plug in. You could plug 0, you could plug 1, negative 3, 5, or 4. The outcome will always be the same. Okay, so this is not a one-to-one. Each value of x does not have a unique value. All these have the same value, so it's the same value here. So it's basically many to one. If you put it like this, it's not a one-to-one like this. For example, if these were different numbers here, instead of 2s, we had different numbers, then it would be one-to-one. But this one is many to the same thing. It's like plug in different fruits and get in the same juice here. For example, you plug apples, you get the same juice. You plug in bananas, you get the same juice. This is not a consistent function. So this is not one-to-one. If it's not one-to-one, then if it's not one-to-one, what do you say about the inverse? Say again.
There's no inverse. There's no inverse if it's not
Exactly.
1-to-1.
Exactly. If it's not one-to-one, there is no inverse. Fiona, does that make sense now?
Yeah.
Okay, so first make sure your function is one-to-one. One-to-one, one-to-one, exactly. For each value of x, there's only one unique value for the y. In other words, the x's here cannot share the same value.